Welcome back. For those of you who are joining us newly, this is the second of our sort of 4-week short course on how to green your home. Every week we've got experts in energy efficiency and deep retrofit of your home for you to speak to, get your questions answered and find solutions to fit your own home. So just a little bit of housekeeping. This webinar is being recorded, so the recordings will be available on our website afterwards, along with presentation slides. If you don't want to appear on the recording, please could I ask you to switch off your video and your microphone, and you can also change your name to an anonymous name if you don't want to be seen on the recording. A big thank you to everyone that has joined us and everyone that has donated towards this course. It's been wonderful, the response that we've gotten. If you're interested in donating in future, you can actually do this through our website or through Eventbrite. So I'll just show you on our website how you can find out how to do that and where you can access the recordings as well. So if you go to cells.org.uk, across the top we've got sort of different news stories, but you want to jump onto the How to Green Your Homes short course. And this page has all the details about the webinar. So the recordings are found right at the bottom of the page, and you can just go ahead and click the video to watch the video, scroll down to see the comments. All the presentation slides are available in PDFs on here. If you've signed up through Eventbrite, we will send you a link to this directly to your inbox once we upload the recordings on there. But if you're interested in donating, or if you want to sign up for our next 2 events, you can go ahead to Eventbrite as you did for this event, select a date, and then you'll be given the options of dates, and you can go to tickets. And then you can just type straight into the donation section, and the minimum donation is £1. All the donations do go towards our fuel poverty alleviation work and also towards our carbon emissions / community work. So it's a very good cause, if I do say so myself. But yeah, we really appreciate your support on this one. And a big thank you to the Big Lottery for helping us fund this course as well. So a little bit about me. Hopefully most of you are familiar with me now. If not, I'm a project manager and director at Celsi. I've been working in renewable energy just for a few years now, but in that time I've managed to fit in a very fun and exciting amount. So last year I worked at the Renewable Energy Association, and I wrote a briefing on homes fit for the future, how we need to build homes to meet our zero carbon targets. I've also managed to pick up a few awards along the way, which have been great fun. But if you need to get in touch with me, my email is just down there. It's nadia@celsi.org.uk. So a little bit about the course, very briefly. We've got 4 sessions. First session last week, we looked at energy efficiency and building fabric, and that was really an introduction to the course. We looked at what the Green Homes Grant is and what it funds. And we also had our expert guest speaker last week was James Trainer, who talked us through the basics of energy efficiency and why fabric first is the best option that we take when we look at deep retrofits of the home. Today, we're delving into sustainable building and insulation. So I'm going to talk you through how you can actually apply for the Green Homes Grant. And then Nick will go on to give you a bit of a deep dive into older buildings and why air-tightness and insulation is important, looking at different types. And he's been through it himself, so you can ask him about his experience, the practical solutions of retrofitting your home. Then we're going to go on next week, a October half-term break. For those of you that have kids, I'm sure you'll be relieved to not have to try and watch a webinar with them running around in the background. And the week after, we're coming back on the 4th of November for a chat with Harry, who has had an experience of retrofitting his own home in southeast London. So he's going to give us a case study on that, and details about working with the contractors, what he dealt with, how you can find contractors that are reliable yourself. And then the last week, we are focusing on renewable energy and how to utilize renewables for your home, but also what it means in terms of the wider energy system and our renewables or zero carbon targets and transition that we're trying to get to. So that brings me on to today's session, a little bit of an agenda. So we're going to talk about first Future Fit Homes, which is the program that this webinar is run under by CELSI, and the services that we're offering, and hopefully our launch, which should be at the end of this course. We're going to talk about how you can apply for the Greener Homes grant, what application includes, all the steps of that process. A few quick tips, and we'll go for a question and answer session just after that. So if you have got questions, please do leave them in the chat section, and we'll address them then. And then I'm going to pass over to Nick Parsons, who is our expert guest speaker for today, and he's going to talk about sustainable building and insulation. And then we'll also have a question and answer session after the questions. So what are you going to come out with at the end of this session? Well, by the end of today, you'll be familiar with what Future Fit Homes is and how we help you green your home and go through the deep retrofit process. You'll understand what goes into applying for the Greener Homes grant, and also how switching energy supplies is a bit of a quick win and easy way to reduce your carbon emissions and your energy bills at the same time. And then Nick is going to help you understand and identify the core drivers of different methods that are used for retrofit, understand what the common hazards are, what are the issues that are going to come up most frequently. You're going to be able to identify different types of wall and floor insulation, and also understand what a thermal bridge is and what a thermal bypass is as well. And I'm very excited to find out a bit more about that myself. And finally, why air tightness is crucial when you're thinking about deep retrofit. And you'll get your questions answered, of course, as well. So a little bit about Future Fit Homes. Really, the aim of this programme, which was set up by CELSI, is to create a greener and cleaner London. We have trained domestic energy advisors, or DEAs, who can help talk you through the process, who can come to your home, complete a full energy audit of your home and work out a plan for you to go ahead and get your work done. We're also members of Retrofit Works, which is a cooperative of trusted, vetted, very actually heavily vetted contractors and installers that can get that work done for you. And any surpluses we do make off the Future Fit Homes programme will go back into our community work, which I'll touch upon a little bit later as well. So we have a number of services through the programme that you guys can access if you're in Southeast London. So that includes Lewisham, Greenwich, Bromley and Bexley Heath as well. If you're outside of Southeast London, I'll touch upon where you can find your local group and see if they're offering any services to do with deep retrofit as well. But coming soon, and hopefully we're looking to launch at the end of the course. We're just setting up the final few bits of agreements and internal work and making sure we're ready to go. So we'll be offering free telephone consultations that will help talk you through really the first steps of understanding what you need to deep retrofit your home. We're going to offer a home energy audit and a whole house plan. That means going into your home, understanding exactly how you use your energy, what the building fabric of your home looks like, what measures you've got done already and what you could still have done. And then create the whole house plan, which looks at your needs, your wants specifically. So are you interested in lowering your bills, using less energy? Are you interested in mainly focusing on your carbon emissions? How big is your budget? Do you want to have your floors taken up, and can you deal with the hassle of having big works done to your home, or is that not what you're looking for? So we'll go through the whole plan, create a plan, which means that you can go out to contractors and you can tell them, this is exactly what I need, please quote for this. We'll also be able to do thermal imaging. Thermal imaging is where we go around your home with a camera and we figure out all the little places where your home is leaking heat. It's amazing to see, because you wouldn't realize how easy it is to see where your home's leaking heat with this thermal imaging. But that will launch sort of probably mid-November, because it's easier to do when the weather is a bit colder outside as well, and it's you can see the results a lot better when the weather is cold out. Is basically a document that gives you a very quick summary of how efficient your home is, and it grades it on a scale from A to G. So you can compare the efficiency of your home with lots of other houses around the UK. And it also gives you your top recommendations for improvement. So it will tell you, for example, if your home is in Band D, you might need to add in some loft insulation, get some solar panels, and add cavity wall insulation to meet Band B, for example. So it is useful to have, and it's also useful on a sort of national scale for the government and for research organisations to be able to understand where the UK is at in terms of its decarbonisation. And then the last of the services we offer is retrofit coordination. So if you decide to go with a contractor from the Retrofit Works Cooperative, we'll help manage that whole process, dealing with who's coming into your home, dealing with when they'll be there, making sure that they've done the work to a high standard as well. But if you're interested in some sort of handholding, or if you've already appointed a contractor that you started to work with, but you do want to check their work, get in touch with us and we can help you figure out that process on an hourly price rather than through Retrofit Works if you've already chosen your contractor as well. So a little bit about Celsey. Hopefully a lot of you are already familiar. I think some people here are probably investors in Celsey as well. But we are a community energy cooperative based in South East London. Our aim is to create a low carbon future where everyone can access affordable energy and has a voice in how it's produced. That means no one is left behind. So we're a community benefit society with a cooperative structure. So everyone that's invested in us has a say in how we're run. We've installed solar panels on around 14 sites across Greenwich and Lewisham. They include schools, community centres and leisure centres. And we also offer free and impartial energy advice to help alleviate fuel poverty. You probably weren't aware that South East London is one of the worst areas across Europe for fuel poverty. So we've got a huge task ahead of us, but we've managed to do really well, especially during COVID. We've actually extended our services throughout the whole year, when usually we only run them over the winter period. And we're powered by a lot of wonderful volunteers. So over 10,000 volunteering hours have gone into what we do at Celsey, which is amazing. And we've actually stopped counting now because 10,000 is a bit too much for us to count. So if anyone has just joined the webinar now, well done. We have got to one of the important bits, which is how you can apply for the Green Homes Grant. So last week, we actually covered what is included who's eligible for it. And we went into quite a bit of detail. So if you're interested in finding out what measures you can get, do go ahead and watch the recording from last week. But this week, we're just looking at the process for applying. So there are kind of 5 key steps to the process. The first, check you're eligible, check you can access this funding. The second is to create a whole house plan, figure out what you need, what your interests are, and what is best for you. Third, find an installer who is reliable, who gives you a decent price that can do the work, and someone you feel comfortable working with, because it will be, you know, a drastic amount of work that is done to your house. So make sure that you do have a good relationship with them from the beginning, and hopefully at the end as well. Then you apply online to get your to get your measures done, or to get your voucher, sorry. And then you will get your works done and you'll receive the voucher after that. So I'll talk you through that in a little bit more detail. So how do you check your eligibility for the Green Homes Grant? There are a few bits you need to be eligible, and we did cover this in detail last week, so check out the recording if you want more information. But you should be a homeowner or a landlord. If you're a homeowner, you can actually you might be able to access more funding, up to £10,000, and you may not need to contribute to the measures if you're on low income. So there's certain benefits that you need to be receiving to qualify for that. Off the top of my head, I think it is income support, ESA, and 2 more types of benefits that you will need. Your property must be not necessarily a very old property, but it can't be a new build that's never been lived in before. And you can't access this if you're a tenant. But if you are a tenant, you can go through certain surveys that will help you understand what your landlord can do and how your landlord can access this grant. So it is worth understanding what measures you can take so that you're able to inform them. And if they can access the money, there's definitely an incentive to get the work done. So the second stage is developing your whole house plan. What does it mean? Well, the first thing you can do is start with the recommendations on your energy performance certificate. As I said before, if you've recently bought your house, or have been looking to sell your house, or your property was rented or is rented, then you'll definitely have an energy performance certificate. If you go to the bottom of the form, you'll be able to find the recommendations in there, and it will give you the measure. So say, for example, you know, loft insulation, it'll give you an approximate cost, which is not necessarily 100% accurate, so it's definitely worth checking out. Usually the costs are probably a little bit higher than they would be in reality, but you should have and it will give you a recommendation of what it will take your rating from in terms of A to G. This thing you can do is try an online form, especially if you don't have an EPC, it's worth doing this. And there is one available on the government website, but there's also a more detailed one that we'll be working with when we launch. So you can access that from our own website, or if you speak to one of our energy advisors for a telephone consultation, they'll actually be able to go through the online form with you. And in an online form, you would put in a bit of information about what type of property you got. Is it detached or semi-detached? When was it built? Have you had any measures done before? And that will give you a bit more detail on what steps you can take and what measures might be right for you. I would say if you're looking to do just a small number of things to your house, it's definitely worth going for the online form. If you're looking at a full retrofit, I would 100% recommend doing a full energy audit of your home and getting a detailed whole house plan, because the plan is very important to making sure that you sort of stay on track when you're getting your retrofit done. So CELSI can provide a full energy audit, and we can either go into your home and do this, or we can do it on the phone remotely if you're isolating at the minute. And we will collect a lot of data on what's present in the home, the building fabric, and then we'll discuss your recommendations with you, and we'll create a whole house plan based on what you find most interesting, what you think is most important to you, and what your budget is as well. So once you've got your whole house plan, the next step is to go ahead and find an installer. When you're looking for an installer, do make sure that they've got the certifications that are needed. There are two main certifications. The first one is a certification through Trust, and that is sort of the body that certifies them, and that is for people that are installing energy efficiency measures. The second certification is MCS, or the Micro Generation Certification Scheme. And you can find out more information about them online, but that is needed for anyone that's installing renewable energy technologies. When you go out for quotes, for the grant, you only need one quote, but we recommend, and the government recommends, getting at least 3 quotes to compare. If the quote that you've got and you submit for the grant seems very high, the government can actually come back and ask you more details about the quote, or they can ask you to get a different quote for the work. The third thing you can do, if you get a whole house plan done through CELSI, we can then go to Retrofit Works Cooperative and give them that whole house plan, and they will search through all of the installers that are registered with them, who, as I mentioned earlier, are quite heavily vetted. Since we're part of the co-op, we trust the installers that they work with, and they'll get you the best quote out of a number of installers in your local area. And you will, if you go with that, you will be able to have works managed by one of our team who is a retrofit coordinator. So that means it's less hassle for you. It's more easy to understand when people are coming in and out of your house, more easy to understand if the works have been done to a high standard or not. And if you're getting a lot of work done, there'll be a lot of different contractors involved in the process. So it's definitely easier to have one port of call for all of that work. So for the grant, when you apply, you can also use more than one installer for different measures. You do need to put in all the different quotes onto your application though, if you are using different installers. And if you want some advice on this, give us a call, and we'll be able to help you out with it as well. So third step is doing the actual application. You can apply for the grant on the government website, and you apply for a voucher. So you need to send in the quote that you've got from your contractors. If you've got multiple quotes, you only need to do one application, but attach all of the quotes that you've got. And when I say multiple quotes, I mean pick one contractor that you want to go with for one piece of work. So let's say you're getting insulation done and you're getting solar panels. There'll be 2 different contractors that are doing that, but you need to attach both of the quotes from both of the contractors. If you've got 3 quotes from solar companies and you've got 3 quotes from people that install insulation, you only need to send the quote that you want to go with in your application. So you will get separate vouchers for every measure that you put in, or every measure that you're getting done, but you only need to apply once. You only need to do one application. The vouchers are going to be issued from the middle of November, and they're valid for 3 months. That's important because if from the date that you get your voucher, you have 3 months to get all the work done. There are some issues around this because, as you can imagine, there's a bit of a backlog right now of interest, and a lot of installers are very busy at the moment. But you can apply for this until the end of March 2021. So you have a little bit of time, but you will need to have your work done by the end of March 2021 or the end of the 3-month period, whichever comes first. The last thing is, don't start any of your work until you get the voucher, until you know that you have been approved, because any work that is done before then, anything you've paid for before then, won't be paid for through the voucher. So the last stage is getting the work done and redeeming your vouchers. So when you get your works done after your application's been accepted, you will need to pay a deposit to your installer. If you're not on low income, then the installer can't charge you any more than you're contributing for the deposit. And we know that for people that are not on low income, the government, I believe, will pay for 1/3 of the work that's being done, or up to 1/3 of the work that's being done. There is no deposit for people that have gone through the low income application, as long as the work costs less than £10,000. Over £10,000, the installer might charge you a deposit for that work. So you complete your works after you've confirmed that your work has been done to a high standard, after you confirmed that it was done before the voucher expires. You need to have received all of the documents that are linked to your installation. So if you've got a renewable energy installation, you need to receive the documents that show that that installation is certified before you can ask to redeem the voucher. You need to demonstrate that you've paid your share of the works that have been done. So that is the deposit and the rest of the money that you are paying for the installation. You need to also demonstrate that you've met the eligibility criteria, and you need to give the government a copy of the installer's invoice as well. And once you've done all of that, after the works have been done, then the installer will get paid directly for the work. None of the money will go to you as the homeowner or landlord. So that covers it for the Greener Homes grant. If you've got questions, I hope that you are putting them in the chat. I can't actually see the questions at the minute, but we'll get to them in a sec. So there are a few bits that you can do right now, which are very easy wins. And I want to show you one of those things that you can do. So the Energy Minister has said, today's figures show the benefits of switching supplier. Switching supplier, not many people do it. I think probably about 1 in 5 people do it. Most people move into a house and just stay with the supplier that was there before. Kwasi Kwarteng said customers can potentially save around £290 a year on their energy bills. So if you haven't looked into switching your energy supplier, I would definitely recommend doing it. And I would definitely recommend switching to 100% renewable energy tariff as well. So look out for that. But we've partnered with Co-op Energy so that you can join a tariff that is completely powered by community energy groups like us around the country. So you can find out more on our website, but I will just take you to where you can see that on our website so you can get an idea about how to do that. So this is our website. It's the first news story, Power Your Home with Community Energy. So if we click on there, you can find out a bit more information about the partnership with Co-op Energy, and it is called the Community Power Tariff. And for every person that does switch to this tariff, Co-op Energy are going to donate £20 to Celsea to help alleviate fuel poverty. and they're also going to donate another £10 into a pot for community energy groups across the UK. So it is really helpful in supporting community energy groups around the UK. But you just click this link and you'll be taken to the Co-op Energy website, and then you enter your postcode and you can get a quote there. And these are the 3 tariffs they've got. Community power tariff is the one where they are donating to community groups. So yeah, check that out if you're interested. But I would also recommend going and looking on a switching website so you can compare different tariffs as well. So what about if you're not in Southeast London? Well, the first thing is you can switch supplier anywhere in the country. So you can use that tariff anywhere in the country. But if you want to get energy efficiency works done and you are outside of our area, then you should definitely visit the Community Energy England website. Community Energy England are like a hub of community energy groups across the UK. And you'll find that there is a map of all the groups around the UK, and you can zoom into that map and see what is closest to you. Or you can just type in your postcode and it will zoom straight in for you. So you can see here what groups are near us. So that is Southeast London Community Energy there. We've also got Sustainable Energy 24 close by, Rosendale Energy, and a few more. Or you can filter by your region and by the project type and by theme. So you can go for energy efficiency, etc., etc. Yeah, so if you're not in Southeast London, do check that out. There's also Community Energy London for if you're in London, which lists all of their members as well. But I think now we will get into the Q&A. So let me just open our chat here. How are we looking? So we have got quite a few questions. Black and Green are asking, do we have EPC or energy assessors? So we have both. We have someone that can do an energy performance certificate for you, and we have trained and qualified energy assessors that can do the whole house plan for you as well. Can we get a whole house audit if we're not in the Chelsea area, or who gives them out in North East London from Roof? I'm afraid you can't get it done by Chelsea if you're not in our area, but definitely check out the Community Energy England website. I can't think of what groups there are in North East London. There might be some groups that are even more local to specific areas than just the Northeast. So I would say look at Community Energy London website or look at Community Energy England's website to find out what's near you. So David J has said that the timing seems insane. Effectively, everything has to be spec'd by the end of December, then done in the following 3 months. And COVID will have an impact on the timings as well. David, I agree with you. It is quite a tight time frame. The Green Homes Grant is a contribution towards the work that you want to get done. And it is a fair contribution, but if you're going to be getting the works done anyway, then there's probably not a rush to apply for the Green Homes Grant. If you're just looking to lower your carbon emissions to invest in your home, then you might not necessarily apply for the grant. We have a lot of people that are interested in it, interested to do these assessments just for maybe their sort of 5-year plans or 3-year plans. So you can get your home assessed, you can get a whole house plan done. You don't necessarily have to do the work now. You can wait until you've got the money to do what work you want to have done. So in terms of actually applying for the grant, there was one more thing that I did want to show you, and that is where to look on the government website. So this is the page for the Green Homes Grant. On here you'll find all the information, and if you just click how to apply, then it will give you the different steps. With the first one, checking your eligibility, you will be taken to a form from Simple Energy Advice that will take you through it step by step. And that's a really easy way to check if you can do it, if you can use it or not. The other thing you can do is check what measures might be suitable for your home. Again, this is one of the online forms that I was talking about through, this one's through simpleenergyadvice.org, and you just enter your postcode and it will look for what measures you can have done through an energy performance certificate, and it lists which houses have them here. If your address isn't on this list, then you can give them your details yourself. It's not too detailed. I would say the one that we'll be using is, yeah, it's a bit more detailed and it's a bit more reliable. And I'll post the details to that probably in one of the next webinars as well. So I think without further ado, we will move on from the question and answer, and I'm going to introduce our next guest. If you have any more questions, feel free to get in touch with me. It's nadia@celsey.org.uk. If you're interested in getting works done, please do get in touch with us. Right now, we are only really taking your details so that we can get you booked in as soon as we launch. If you do state your interest now, then we can get you booked in before anyone else. But I'll just show you how to get there. So if you go to our website and go to the page where we've got details about this course, and you can just click here to register your interest, and you'll be taken to a form where you can fill out your contact details, what services it is that you're interested in, and a few more details. It doesn't take longer than sort of 1 or 2 minutes, and we'll call you back as soon as we launch and get you booked in and let you know the details about prices and services, etc., etc. So that is on our website, and I'll send round the link through an email afterwards as well. But let us get started with Nick's presentation. So I'm very excited to have Nick here. He is extremely experienced in this area. He's been in the community energy and sustainable building space for a very long time. So Nick Parsons is a freelance sustainable building consultant, and he trains other people on how to do this. He spent 10 years running a community energy project in Sheffield. His main focus is on older buildings and deep retrofit, but he also looks at very complicated types of insulation and air tightness issues as well. He used to be a lecturer at Derbyshire Eco Centre, and now he lectures at the Centre for Alternative Technology in Wales, which a lot of you will have heard of because it is very famous for everything renewable energy, sustainable building, carbon emissions reduction linked. So I will pass on to Nick. We'll have questions at the end of the session, but in the meantime, do feel free to drop them in the chat and we will get to them there. So I'll just stop sharing my screen so you can go ahead, Nick.
And I'll start sharing mine if I can, yes. Right, hello everybody. Those of you who were looking at that last picture there will have seen that I've not aged well since that photograph was taken. If you think I look about 10 years older than that photo, that's because I am. Okay, so I run Nick Parsons Sustainable Building in Sheffield, which consists of Nick Parsons, basically. And as Nadia said, I do surveys, consultancy. I hold people's hands for them where necessary. I will sometimes be contacted by architects who say, well, I'm interested in doing this new stuff, but I'm not really an energy architect. And the client will say, well, I'm interested in this energy stuff, but I don't really know a lot about it. So I sort of hold their hands and act as a critical friend between the two of them. That's sort of roughly who I am. As Nadia said, I teach at the Centre for Alternative Technology. I do the odd session on their MSCs, and I run the 4-day eco refurbishment short course a couple of times a year, but not this year, as you can imagine. How did I get here? Well, I just pulled up a chair and here I was. I worked for nearly 20 years for an inner city housing association. And at the time I started, all of our houses were refurbished. We didn't have any new builds. And they were done according to the housing association cost limits at the time. This was in the early 80s, and the cost limit wasn't terribly generous. So you'd get a new roof if you were lucky, damp-proof course, timber treatment, damp-proof course whether you needed one or not, timber treatment, new windows, single glazed of course, and you'd get loads of condensation as well, because the houses didn't have central heating and they weren't heated enough. We were looking after people at the bottom of the income tree, and they couldn't afford to heat the homes properly. So we gradually got, the early 80s coincided with an improvement in the cost limits and the amount we got for each refurbishment, or rehabilitation as housing associations used to call it. I used to talk about rehabilitation and people thought I was in a completely different field. We were actually able to start pushing the envelope, as it were, and start doing internal insulation of solid external walls and so on, which really in the housing association movement, hardly anybody was doing at the time. So we were quite a front runner. But as I will show you as we run through, what we were doing then is not necessarily what we would do now. So does it really matter what you call it? Lots of people say retrofit. I prefer to sort of preface things like this with green or eco or whatever, because retrofit to me can mean just doing a place up. Doesn't necessarily mean that it's going to be to a very, very high energy performance. Green retrofit, eco retrofit, eco refurbishment, rehabilitation, doesn't matter what we call it as long as we know what we mean. You'll notice I'm talking very fast. That's because I had to promise Nadia that I would have my turbocharged mouth on tonight in order to get through the entire presentation. So what sort of building needs an eco retrofit? I would argue pretty well everyone. Because if we're looking at zero carbon by 2050, or even sooner if we can get there, then we are going to have to decarbonize pretty well everything in our buildings, which will mean, we could say, okay, we'll just take out the gas boiler and we'll put in a heat pump and run it on a renewable tariff. Well, I don't think that recognises the fact that with the electrification of transport and so on, demands may be too great. And in any case, if we've got a leaky house, why on earth should we try and run that on electricity without improving the performance of the house so that we have to put less heat in? That's my mantra. The better insulated it is, the more airtight it is, the smaller your boiler or whatever is going to be. So what are our motives? Carbon reduction, good. Energy efficiency, good. Comfort, yep. We all want to be comfortable. Health, smaller fuel bills. Let's not knock that one. And increased value. Increased value is a tricky one. People say, well, surely if you're doing all this stuff, it will increase the value, won't it? Well, not always. The problem is people buy houses and they come into them with their own ideas, and people may well alter the house in such a way that actually undoes some of your energy efficiency improvements. And also, I really, really wish that people would base part of their home buying decisions on the EPC. Would help if the EPCs were more accurate, because they are based on reduced data, SAP, the Standard Assessment Procedure for the Energy Rating of Buildings, and that can only be as accurate as it can be. But if people said, no, I'm not going to buy this one because I can see it's going to cost me a fortune, it would actually help the market to become more energy biased. So how much energy does go into space heating for your home? If anyone's looked at the passive house standard, or EnerFit, which is the passive house for retrofit, they'll have seen figures for new build like 15 kilowatt hours per meter squared per annum for space heating, which is very, very low. 25 for EnerFit. The AECB, the Association for Environment Conscious Building, their silver standard, 40 kilowatt hours per meter squared per annum. Now, picked up some figures from a student passive house conference a few years ago. Very pessimistic estimates there. Pre-1945, maybe as bad as 250 kilowatt hours per meter squared per annum. As I say, OVO Energy guesses about 100 kilowatt hours, but it's an awful lot more than ideally we would be if we could get there. What are the sort of drivers? CO2 reductions I mentioned. You might want to avoid petrochemicals. I don't want to heat my house with fossil fuels. But what about, for example, insulating your house with fossil fuels? Because if you buy a lot of the modern insulation materials, they are made from petrochemicals. And as I said at the beginning, to some extent, whatever you call it, the important thing is that you're happy with it. And if you are happy to say, right, I will use petrochemicals as an insulation board in order to reduce so that's a capital cost, and in order to reduce my revenue use of petrochemicals in paying my fuel bills, well, that's a legitimate sum that you can do. Not everyone will agree with you. There are some people that say to me, you shouldn't be talking about eco refurbishment and mention plastic insulation in the same breath. Well, sometimes you have to be pragmatic. Sometimes there are situations where you will use them, and I'll come to those in a bit. Avoidance of hazardous materials. I'm going to frighten you in a bit. Use of natural materials, use of breathable materials. Cost is one thing. As I say, whose list is right? The important thing is that you're happy with it. Things will change. Get advice. Ask Celsi, of course, if you're in their area. I will put my contact details at the end. So if anyone does want to contact me, you know, if it's a quick email, I'll answer a quick email. If you want loads of my time, things happen, things apply there. I'd have to ask you for money. I'm not touting for business. I'm also in the wrong place. I'm 200 miles away from you. So, if anyone wants, drop me a quick email with a question after this, that's fine. Limiting factors. We've got loads of limiting factors: listed buildings, conservation areas, national parks, planning rules, building regulations. Well, wouldn't actually call that a limiting factor, but it's something that we've got to comply with. CDM, the construction design and management regulations, which apply to us all. They used to apply to only bigger building projects, but they apply to us all. And it's interesting to have a look at the government's website for CDM and actually see how it applies to you, or how you divest yourself of the obligation when you get a builder. Have you got to get permission from the freeholder? Have you got to get permission? Have you got to inform your insurance company or lender? Lots of people put in wood burning stoves. Insurance companies quite like to know if you're increasing the risk of burning your house down. So there are things like that. Practical and technical stuff which might limit what you can do. The building form. Have you got a very high ratio of external wall area to floor area? If it's a detached house, yes, you probably have. So you're going to have to work harder to keep that house warm, and your own wishes, including aesthetics. If you don't like the way that it looks, or another member of your household doesn't like the way it looks, then you may not do it. So basic aims: set your retrofit project brief or your shopping list, doesn't matter what you call it. Find the baseline, get somebody to do a survey to find out the existing energy performance of the building, or simply, it's good if you can get a before and after assessment of actually how much it will cost to run. But even if you just break it down into elements and say, right, my walls currently have a U value, that's a thermal conductivity, how rapidly the heat disappears out through things. My walls have a U value of 1.7. If I put this much insulation on them, I can not only comply with the building regulations with a U value of 0.3, but I can reduce my heat loss through that wall to less than a fifth of its former level. Important thing: make good disrepair. Don't let the works you do to insulate your house actually lock in decay behind things, because I'll come in a minute to why that is really, really important. You want to do a bit of a risk assessment. That's not a sort of full works risk assessment that your health and safety advisor might do if you had one, but highlighting the risks for your household. What are the risks of living in a building during works? I can well remember one of my sons many years ago. We were sat in church and he was shouting, "Daddy's got a hammer, Daddy's got a drill, Daddy's got an angle grinder," because I tended to leave my tools around while I was working on the house. Yeah, you don't do that. Risk of running out of money, risk of running out of enthusiasm, or running out of hope. Don't do that. Refer to the plan. So we'll talk about the plan. But there might be lots of hazards in what you're doing. There are lots of hazards during works. You can't help it. What you have to do is manage them away. Some are pre-existing, and here's a few. Asbestos, for example. What's asbestos in here? Well, a lot of these fascia and soffit boards, maybe. Vinyl tiles, asbestos. Yep, quite a lot of older tiles had asbestos in them. Corrugated asbestos cement sheets, but also fibre cement slates, which an awful lot of us will see. Until the 1990s, they contained, a lot of them contained asbestos as reinforcement, and the site guidance at the time was cut in the open air. Asbestos gutters and pipes, down pipes, soil pipes. Replacement UPV soffits and fascia boards. What's that got to do with asbestos? Well, I did an external insulation job on a house a few years ago, and it had plastic soffits and fascias, and it was 1960s. And I just had a nagging thought. So I said to the client, or I said to my colleague, can you just pull back one of the plastic fascia boards and just see if there's anything underneath? And sure enough, underneath was the original asbestos boards. Now, the client then had to arrange for those to be taken off, because otherwise we couldn't do a decent joined up job on the external insulation to actually properly join it up to the roof insulation. I never found out how much that cost, but I'm sure it's not cheap. Textured coatings. Because I'm not always very clever, it took me a long time to work out what ARTEX stood for. Asbestos reinforced textured coating. So not all textured coatings had asbestos in them, but many did. And it is worth getting peace of mind. Loose asbestos insulation, you won't often find this in houses as far as I know, but it does look alarmingly like recycled newspaper insulation. So it would be possible to scare yourself greatly and think you had asbestos. Asbestos testing is relatively cheap. I would say, if in any doubt, get it tested, because you see a lot of posts on DIY and building forums by people saying, help, I'm losing sleep because I really fear that I've exposed asbestos and so on. If they haven't checked it, they can't find out. In the worst case scenario, you have, and you have to act accordingly. But if there's if you think there's any materials in your house that might have asbestos in them, then get them checked in advance. Volatile organic compounds, more or less anything you can smell is a volatile organic compound. So typical ones you'll come across in building, well, perfumes, not so much in building really, paints, formaldehyde, glues, etc. B&Q were really early adopters of labeling of paints for volatile organic compounds, low, medium or high. Timber treatments and damp-proof coarse injection, certainly have been some suggestions in the past of potential harm to health from solvents in old treatments. Respirable crystalline silica. There are some fairly beefy regulations about this on the Health and Safety Executive website, which is worth looking at, both for asbestos and all sorts of building health and safety issues. The Health and Safety Executive reckons that this is sort of second only really to asbestos in cause of lung disease for people working in building. And it's about, you know, grinding out concrete, bricks, whatever it might be. So you need to be careful. Dust generally, any works you do are going to create a lot. Compartmentalize as much as possible. Don't just hang a sheet over, tape plastic over doors and so on. If you can actually tape yourself into the room you're working in, if there's another exit, that's not a bad thing. And vacuuming creates a lot less dust than sweeping. Lead, another hazardous material. Lots of houses have lots of lead left, water pipes, lead flashing, lead paint. But lead makes really, really good flashing for roofs and so on. It's very long lasting. I've seen zinc flashings peppered with holes like a colander, where lead is still going strong after 150 years. So sometimes it's a question of saying, right, well, we know there is a bit of a risk to this, but let's use this in a low risk scenario. Lime, many older buildings benefit from the use of lime, but it can be nasty, it can burn you. And sensible risk assessments and precautions are required. Again, formaldehyde, it's a volatile organic compound. You know, the new carpet smell that you get in carpet shops, that's formaldehyde from the glues in synthetic carpets. Formaldehyde actually makes a really, really good glue. I was terribly upset when I discovered that my favorite boat building glue was formaldehyde based. And lots of composite materials, chipboard, MDF, OSB, oriented strand board, and so on, are glued up with formaldehyde glues. Not all are, and there are some low formaldehyde boards. Wood, timber contains formaldehyde naturally, so you're very unlikely to get zero formaldehyde timber products. It does off-gas into houses, and if you have poor ventilation, you may get you know, irritation of the eyes and nose and throat, and rarely asthma. And again, this isn't quite a building material, but a material connected with buildings in some areas. Radon, down in Cornwall, where, you know, you sort of walk with a radioactivity meter through some of the granite areas, and it'll be bipping at you like nobody's business. Where I live, not so far away, there's fairly high risk radon areas, and this means that you have to take precautions with putting radon barriers, big thick deep damp proof membranes underneath floor slabs and so on. And increased exposure to radon increases your risk of lung cancer. Radon UK, ukradon.org is really good website. Squirty foam, expanding foam, polyurethane foam, and other aerosols. The propellants may be corrosive, fumes can be harmful in volume, and if you are, you know, you're lying underneath the floor trying to seal around the perimeters of a suspended floor, and you've not managed to keep the can completely upright, and the can starts sputtering, what happens there, I can tell you from personal experience, is that it's delivering the propellant, which is somewhat corrosive, rather than just the foam. That can then bounce off the wall and underneath your safety glasses and take you to the eye casualty. Don't ask how I know that. So serious precautions are necessary. back to more fundamental aims. Plan any alterations to the internal space or any extensions that you want to make, because you don't want to kind of box in your future plans. Oh, I've insulated this wall, I was going to knock it through into an extension. Well, don't insulate it if you're going to, if it's not going to be an external wall anymore. So try and get your plans as long term as you can, even if you're going to not do it in a rush. Adopt a fabric first approach. So basically, don't make the first thing you do to bolt solar photovoltaics, electric solar panels, or solar water heating on the roof or whatever. I'm not knocking those at all. I think they're absolutely great, but I have a very strong ethos that I would like to encourage you to, through air tightness and insulation improvements, to make sure that the heat load, the heat loss of your home is as low as it possibly can be. So when you come to put the heating system in, it's a much smaller heating system. So assess and address air leakage, plan in your air tightness layer. There wants to be an air tightness layer all around your house. That could be hard plaster on the walls, but then that's got to extend above the ceiling through past the first floor, because otherwise we build joists in there. We don't build them in very well. They're not at all airtight. So planning your air tightness layer and planning the junctions. What will it be made of? As I say, it can be plaster on the walls. It can be membranes in the ceiling. It can be membranes in the floor. It'll probably involve some very, very sticky air tightness tape where you're taping in windows and this sort of thing. But how are you going to connect it? If you have got an air tightness layer, a vapor control layer on your roof, underneath the insulation in your roof, how are you going to connect it with the air tightness layer down on your walls? Are you going to be taking up the floor so you can connect the two? If you're not doing the jobs at the same time, how are you going to achieve it, and so on? It's not easy. Design in your insulation. Watch out for thermal bridging and poor detailing, and don't make it look wrong. Concentrate on getting these bits right. And as I say, the bolt-on goodies such as renewable energy can come later. Ideally, move out, to be frank, but many of us don't get that chance. So do it in bits, but plan for the whole. Lots of people say don't try and do one room at a time, but we have to. So do the whole house plan and then organize the increments and then plan the connections. So if I'm doing my living room, I will cut back the ceiling. If I'm internally insulating the external walls, I will cut back the ceiling. I will, because there won't have been any plaster in between the ceiling and the upper floor, obviously, I will plaster that with lime plaster. I will, when that's dried, I will tape around it to the joist ends, and I will carry the insulation on up to the bottom of the bedroom floor. Then when I come to insulate the bedroom in the future, I cut back the floorboards and whoopee, there's my insulation waiting to be connected to. So avoid doing it twice. And I do have a story. 33 years ago, the industry didn't much consider energy efficiency and renovation, and you had rather clunky external insulation systems. Twillath was one of them, Tinsley Wire, a Sheffield company, expanded metal that you render onto. So you had this sort of metal system which you put rock wool into and then rendered over it. It wasn't as easy to use as the sort of rigid board and thin coat renders that you get nowadays. So I began insulating my house using one of the recommended measures at the time, which was styroliner. 38 millimeters of this blue XPS, extruded polystyrene, styrofoam, bonded to 9 mil of plasterboard. And the thinking was basically, if you just stick this on the inside of your room, then it will be insulated. But look how we stuck it. This is just an offcut I took out when I was taking this out of one of my rooms and doing it properly, which I'll show you in a minute. Blob and dob, dot and dab. That's a typical way of fixing plasterboard or insulated plasterboard. You just fling the stuff at it with a trowel, blob, 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 the adhesive, and then stick it on the wall. But none of us really understood air tightness, including me. Look at these gaps around this window, frightening. So the air from my cellar below this room was just howling up behind there and completely thermally detaching the insulation of the wall. Now, a 9-inch solid brick wall doesn't have a very exciting U value, but it's better than a poke in the eye with a sharp stick. It does give you some thermal resistance. Otherwise, you just stand outside, wouldn't you? So it's important that you don't get air moving between two skins. You want to connect those two skins so that it is the insulation value of one plus the insulation value of the other. So yeah, now we know much more. So my house, good example of doing it as well as was really known at the time, and then discovering that you could have done it better. So what I discovered, and what lots of academics talk about, is the performance gap. So you do a SAP calculation, for example, the standard assessment procedure for the energy rating of buildings, and you say, right, if I do this, 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 and this to my house, I've done a baseline assessment, my SAP is pretty poor, I do this, this, and this, and it will increase my SAP and thus reduce my running costs. And what often happens, you see lots of graphs of this, what often happens is you see graphs of the SAP predicted performance and running costs, and the actual running costs after works, and they're often higher than they say they would be. When you get right down to Enefit and this sort of thing, to the really, really high energy performance, that performance gap tends to be a lot lower. So that tells us a lot, because basically we're not diluting our energy performance by not doing it right. We're doing it all right at the start. So now we try and build tight and insulate right. If all of that completely frightens you, don't do nothing. Do some short-term things. As Nadia said, change your energy supplier. But go for some cheap hits as well. Walk around your house and just see gaps. So somebody's taken out an old waste pipe and they haven't blocked up the hole where it came out. Or someone's put in a new waste pipe and they chopped out a half brick and they put the waste pipe there and they never got around to pointing it up. Go draft hunting. You've always thought, oh, I must get some proper mastic and seal up that the gaps between the skirting board and the floor, but I never quite get round to it. When you think that, go out and buy a roll of masking tape and do it now. Is masking tape the best thing to do it with? No, but it's better than nothing. And if you might otherwise not do it with something quick. You can always come back to it when somebody's bought you a mastic gun and few tubes of mastic for your birthday or Christmas. Seal round pipes, windows, doors, etc. But always make sure you don't reduce ventilation required for open flued or unflued appliances. Open flued appliances, wood burning stoves, gas fires, whatever. Unflued appliances, gas cooker, for example. There's no typical retrofit. I've got a few pictures here. All of those might have an eco renovation. How would we insulate them? How would the planners like it? How would we like it? You know, did we buy our house because it looks like it looks? This one, for example, perfectly ordinary sort of 60s, 70s house. What special considerations might there be? Well, I can tell you it's made of concrete. So you wouldn't automatically do exactly the same things as you would do for a masonry house. The principles are the same, but it may give you some practical problems, not least fixing into the concrete panels. Steel houses, quite a lot of steel framed houses built after the Second World War, lots of them still around. There can be real problems when people insulate steel houses internally, because by putting insulation inside, you warm the room up, but you cool the wall down. So you can end up with the frame rusting badly where it didn't before, because when there wasn't any insulation, you were heating the steel, weren't you? This one, are you going to externally insulate this one? Not necessarily. You may have bought it because it looks like that. This one too, could you externally insulate that? Well, it's a nice looking stone house, isn't it? You probably bought it because it's a nice looking stone house. On the other hand, it has a rendered gable wall. What you can't see, but what I can tell you, is that the house is actually on the corner of the road. There isn't even a pavement. Yeah. So the likelihood is that they can't externally insulate that wall there, that rendered wall, although it won't really make it look any different. They would have to extend the roof line if they wanted to do it, so that the insulation had a roof. But if they probably don't own that airspace. So if they were to add 100 mil of insulation to that gable wall, they would be encroaching on the public highway. It's always something you've got to watch out for. Do you actually own the land that you want to insulate over? And again, this one, you know, the reality is lots of people buy lovely stone houses and lovely houses that are lovely for some reason because they look like that, and they don't want to change the look of them by turning them into sort of rendered concrete boxes, as it were. So the regulatory framework, even if you don't go for something like the passive house version of retrofit, building regs cover an awful lot. Approved for refurbishment, approved document L1B, planningportal.gov.uk. All of the approved documents for the building regs are there, and it's your friend. Lots of people don't realise that they have to actually notify certain building works. I'll leave you to read these. These will be on the website. I'll leave you to read the detail in this because I'm aware that time's cracking on and there's still got to be some time for questions. So the building regs give U-value targets. The U-value is a measure of heat loss. It's how well heat disappears out through the elements of your house. So lower is better. Someone says, oh, I've got a lovely, really high U-value. They've not understood fully. So you want a really low U-value. Just to give you two U-values to put it in context, when somebody says, oh, you need 270 mil of insulation in your roof, well, you don't need 270 mil of insulation. You need a U-value of 0.16. That happens to be a U-value that happens to equate to 270 mil of mineral wool, glass fibre or rock wool. But insulation on top of the bedroom ceilings, 0.16. Windows, 1.6. So your windows are losing per square metre. It's the amount of heat lost per square metre of that building element when it's a degree colder outside. So your windows are losing 10 times more heat than your roof. On the other hand, if you bricked up your windows and insulated them, you'd probably be pretty miserable because your house would be dark and you'd never get any sunlight. So I'm not suggesting you do that, but it's just an interesting comparison. So compare those with Enefit or passive house U values. Typically for new build, you're trying to get low values, U values as low as 0.1. Even in Enefit, you're going to try and keep them round about 0.15. In roofs, you know, I don't think it's daft to put 500 mil of insulation in your roof if it's just a wide open loft space that you're not doing anything else with. And then you might have a U value of 0.09 or something, really, really low value. How do you achieve building regulations U values? If you want to externally insulate your walls, if it's solid brick wall to start with, 90 mil of graphite expanded polystyrene. Expanded polystyrene, the white bobbly stuff that your telly comes packed in. Graphite expanded polystyrene, grey bobbly stuff with a rather better thermal performance. 90 mil will get you that 0.3 U value, which is required for walls. And there are various other fabrics that can be used externally. This is an example of external insulation, left-hand picture before, right-hand picture after. Looks about the same. Different boroughs vary, but in Sheffield, for example, it says that you don't need planning permission, so it's permitted development, provided that the materials used look substantially the same. So basically, had this house just been bare brick before and we'd externally insulated it, we'd have needed planning permission. As it was externally insulated, okay, we were going to make it a bit fatter, but we weren't actually changing the appearance of it. But don't cut corners. This is these are some clips from Passive House Plus magazine, which one of the places I'll recommend you to look at is the Association for Environment Conscious Building. And I'm not their sort of recruitment agent, but if you join them, their house magazine is Passive House Plus, so you get that as part of your membership fee. And they reviewed an external wall insulation scheme at the sort of tail end of the last Green Deal round. And there was some disastrous detailing issues went on there. You can see capping details on the bottom left, which actually tip water back into the wall. You can see fall pipes cut into the external insulation with a gap in the fall pipe, in the gutter, the connection from the gutter to the fall pipe. So that's going to pour water down the back. Top left, insulation which stops before the top of the bedroom ceiling. So there'll be a nice strip of mold, quite likely, on the inside of that bedroom. Even in ones that are done a little bit better, you see the little weak points. On the left-hand picture of this, go up above the front door, up to the gutters, and you can see a little square of something. That's where the house owner wasn't prepared to pay anything more than the basic. So that's where the eye bolt is for the BT cable. On the top right, that's where the high voltage, the mains voltage cables come in to actually supply electricity to each house. So they've cut it into the insulation. And the one I like most, which doesn't work so well, bottom right, doesn't work so well in really small scale. You can see the road sign. They've cut the insulation out around the road sign. This one is an old terraced house with an extension attached, and they've done external wall insulation with brick slips, which actually looks quite good. But they've used at the top above the windows, you can't see it very well because there was a white fascia board behind the gutters anyway, but they've used the insulation sticks out further than the roof does. So they've used an industry standard capping detail, which is a white aluminium trim. And you have to be careful that by using those trims, you don't stop the insulation outside lower than the height of your ceiling inside, because again, you can end up with condensation and mold. Internal insulation of external walls can cause problems because you can get interstitial condensation. As you warm up the room, you cool down the wall. So the dew point, which used to occur at the outside of the wall where water vapor turns to liquid water, comes in and may come in right to the inside of the wall where your joists and your timber lintels and so on are embedded into the wall, and you put them in a very aggressive environment. This is the left-hand picture, impermeable insulant, Kingspan, Celotex, whatever, and permeable wood fiber, which I much prefer on the right-hand side. It's breathable, it's high density, and it buffers moisture. This is my living room, changing from the horror that you saw previously with the styroliner to a really nicely wood fiber insulated room. I could say more, but I am really running out of time. Both external insulation and in most cases, internal insulation will need building regs approval. External wall insulation, as I mentioned, may need planning approval. Breathable versus vapor control materials. Generally, if you can use breathable materials, that's water vapor permeable materials. Breathability, nothing to do with air movement. When energy geeks say it, it's about water vapor permeability. The approved document L1B allows some get out clauses. Basically says if you're using a breathable material because the house was built with breathable materials, you don't necessarily have to achieve the stipulated U value. Well, I'd like to get people to get U values as low as possible, but my living room doesn't quite have the headline U value, but it's still past building regs because I explained why I'd done it. If you can't do breathable, always manage the risks. Get condensation risk assessments done. Don't just assume it will be all right. The more airtight it is, the less bulk air transfer takes water vapor into the wall where it can condense. Roofs, loft and attic rooms. If you want to get loads of insulation in, but you don't want to use plastic insulation, but you've only got 3-inch 75mm deep rafters, you're not really going to achieve it, are you? So often you end up with a plastic insulation in there. Really herring through this now. Ground floors, you can, if you're ripping them out, you can put solid floors in. You can insulate with flexible wood fibre, polyisocyanurate, Kingspan Celotex. And you can't see terribly well on that right hand picture, but I can tell you that water was pouring off that rock wall. Insufficient ventilation, breathable membrane to retain insulation and as a secondary air tightness layer. That's done from a cellar, so that's easy to achieve. Windows, bog standard 1.6, U value for triple glazing, passive house type down to 0.7 or so. Or you can repair old windows sometimes, and don't forget secondary glazing. You might actually do secondary glazing with a double glaze unit. Don't forget thermal bridging. Thermal bridges are weak points. If you're doing internal insulation, you might carry the insulation round onto the internal wall or the party wall, so that you cloak the thermal bridge, which will otherwise occur if you draw an angle through there. If you just stop it without turning it round the adjoining wall, heat's going to disappear out more easily. Thermal bypass is where, like I talked about in my living room with the styroliner and the big gaps behind it, where cold air can get to the warm side of the structure. And if you look at this PowerPoint later on, you'll see this diagram here is a particularly horrendous. This was an extension on a bungalow, particularly horrendous example. Air tightness. Lots of products around, but solid plaster is a really good air tightness layer. We used the original plaster and we just filled in where the original plaster hadn't been on this particular refurbishment. Intello membrane, it's an intelligent vapor control layer. Blower door to pressurize or depressurize your house. Once you're airtight, lots of people talk about mechanical ventilation with heat recovery. It can be difficult, particularly if you're doing an incremental retrofit in bits. It can be difficult to design it in. So you might consider that you have decentralized mechanical extract ventilation. So fans running continuously in your living room and your bathroom with a boost for when you're getting really lots of moisture. And you just add that into the sums and see what the effects are. Well, we're going to be chucking some heat away, but we may have done so much insulation that we can afford to do a bit of that. And that compares with not having to spend X £1,000 on a MVHR system. Now get the heat in. At that point, get the heat in. Once you've done all the good insulation, all the good air tightness, then you engage your specifier, designer, retrofit coordinator, whatever, attain the necessary approvals, find a contractor with the experience. That's a really difficult one. Celsey can help, but roundabout here, there's very few of them. I'm going to retire from site network next year, so there's one less. But you can do a lot if you have a retrofit coordinator. The retrofit coordinator can do toolbox talks, can talk your builder through the way of doing things. Procurement rates, do you have a main contract routes? Do you have a main contractor who takes all the risk, or are you the project manager? If you're the project manager, do you know enough? What sort of contract do you need? Don't forget the construction design and management health and safety issues. Who carries the principal contractor liability? It might be you in some cases. And what about DIY input? If you're DIYing while the builder is on site, does their insurance cover you? Does your insurance cover you? Nadia's just about to tell me to stop. Yeah, for general knowledge, consider joining the AECB, Association for Environment Conscious Building, the Green Building Store, which many of you may know as a green builders merchant. They have lots of resources, videos and so on their website. The Green Register is another one. Ask people who've done it. Look at the Super Homes website and the Green Open Homes websites, and ask Celsey. And you can always contact me. And thank you very much for listening. That leaves us about 4 minutes for questions. I'm sorry about that. Thank you.
No problem at all. Thank you, Nick. That was hugely insightful. If you don't mind, if you could just stop your screen share, and then we'll be able to see you for the questions. So
I will if I can. How do I do that?
just at the bottom of
Stop
it.
share. Yeah, sorry. Yeah.
Thank you. So I hope you enjoyed that. I've just posted all of the useful links that people were asking about in the chat. These will also be sent round via email after the session, and they'll be available on our slides. We'll have links to them when we upload them on our website. If you need to drop off now, please go ahead. We're going to do, I think, 10 minutes of questions, so we will run until 8:10. And of course, you can find the recording on our website. I'll upload in a few days. But let's get started on the questions, I think. So quite a few people, including Tom, Sheila, and Adam, have all asked about the lead times for the work, and that some works might take more than 3 months. Regarding the voucher, is the voucher lost by then? I'm afraid it is. We might see changes to this rule. We often do see changes with the government schemes once they've had a bit of time to figure out how they're running. But for now, you do need to get your works done within 3 months, and they do need to be done before the 31st of March. Black and Green also asked if you can get an EPC on something that's not built yet. No, it has to be built. EPCs are kind of done on the ground. And LP asked if contractors would assess for free if there is cavity wall insulation in her home or his home already. It would come down to the contractor, I'm not sure, but you could get a energy survey done by Celsi or by someone else to figure out what exactly is in your home before you start any work.
If I can I just come in? Where I am, not a lot of help to people down in London, but where I am, a lot of the local contractors will come out and do a couple of holes with a boroscope and check.
Wonderful. Okay, that's good news. So check with your contractor before they'll say yes or no. But yeah, I think it differs among contractors. So first question for you, Nick, from Alex and Giovanna. What do you think about nanotech for external wall insulation? And Alex also said, please can we clone Nick and have a version of him in London?
Well, the joys of the internet, you can have me in London whenever you like. Nanotech, is this a product or just thin technology? I don't know. Yeah, I don't know, I'm afraid. In general, when it comes to thin things, which everyone's looking for, lots of people have talked about aerogel and so on. I tend to take the view that when it comes to insulation value, a thin thing tends to have the insulation value of a thin thing. If it's really, really thin, unless it's phenomenally expensive, it's probably not going to be terribly exciting. But I'm afraid I don't know about nanotech and external insulation. If you wanted to, it may be that I've misunderstood the question. If you want to email me, by all means do.
Right, okay. So the next question is, Ellie says that she has got a building from the 1950s and the floor was tiled when she moved in, and there's a new flooring placed on top of that. Do you think it should be removed? And she thinks it's quite hard to take the tiles up. What are your opinions on that?
What from the point of view of getting insulation?
I would have, yeah, for underfloor insulation.
Yeah, I mean, is this a concrete floor or a timber floor? Do we know?
I don't think we know.
Okay.
I think she said concrete.
Okay, if it's concrete floor, I suppose the first thing, 1950s house, it's got tiles on it. Are they asbestos bearing? So if they look like sort of vinyl tiles, old vinyl tiles, I would very, very carefully take a sample of one and get it tested. Can cost anything from sort of 20, 25 quid upwards. I pay about 65 quid locally, but someone will actually come along, take the sample for me, take it away. You know, it avoids some of the faff. If you don't mind losing a bit of room height, I mean, it works. What I'm about to describe works in bungalows. I did this in a bungalow where we did some external insulation as well. We simply put a floating floor, so insulation vapor control layer, and then OSB, oriented strand board, tongued and grooved, glued at all the joints on top of the existing floor. The client didn't have any friends who were 6'6" tall, so didn't mind losing a couple of inches off the overall height, and that worked really quite well. The increase in insulation wasn't huge, it wasn't 150 mil of insulation, it was 25 mil. But when you do the graph of insulation improvements, the first inch or 25 mil, whatever, is the steepest bit of the graph, and then it flattens out as you put another inch and another inch and another inch. So sometimes just getting anything on at all can be useful. In a house, that's slightly more problematic, because if you put a floating floor on, you alter the height of the first step of your stairs. And that's in breach of the building regulations, because the treads of the risers of your stairs have got to be equal. That's a bit more tricky.
Okay, all right, that's really interesting. So leading on from that, Ruth had a question, and she was saying, if something is 90% airtight, but there is a small gap, is your air tightness 90% effective, or does the gap make it completely worthless?
No, it doesn't make it completely worthless. I wouldn't like to say that if 90% of the wall, floor, roof, whatever was covered with an air tightness layer, and you literally had a 10% gap, if the performance would be 90% of what it should be. I wouldn't like to guarantee that, but the big problems are about getting the joints right, and also with vapor control layers and air tightness layers, not making big holes in them later. One of the reasons why I like wood fiber insulation so much is that it doesn't actually rely on a vapor control layer, because vapor control layers tend to get holes put through them. I'm not trying to be critical of builders and so on, but if you think about it, the builder does a lovely job with the vapor control layer, and then the electrician needs to put holes through, and the plumber needs to put holes through, and somebody needs to fit the kitchen units and this sort of thing. And there can be problems. So planning for the layer is really the most important thing. But no, if you can get a really, really good air tightness layer for 90% of your house, then do it, and just find out ways of getting the last 10% sorted at a later date.
Okay, that's useful to know. So Magda has asked, how do you choose the right heating solution for a retrofit if you don't want to use a gas boiler? Now, we've had some comments from Giovanna saying that often an air source heat pump is the right solution, but you need to have a well-insulated house, and you need a sufficient space outside where you've got a sunny wall. And Alexandra has also suggested that her dad used electric heating in his house, and that's been quite good. But what are your thoughts on heating solutions?
Generally, I don't particularly like electrical resistance heating, so convector heaters or flash wall heaters or whatever. Anything that is just heating an electric element is deemed to be 100% efficient. It is you're getting 1 kilowatt hour of heat out for each 1 kilowatt hour of electricity you put in. But with a heat pump, you're possibly getting 2.5 or 3, or if you're really lucky, 4 units of heat out for each unit of electricity you put in. So I would always look wherever possible for trying to get a heat pump in. But the most important thing, I can understand why somebody might find electric heating useful. It's an awful lot cheaper to install if just electrical resistance heating. It's a series of convector heaters hung on the wall and at a minimum plugged into a socket. But it's incredibly expensive. So obviously, if you went from gas and didn't improve the insulation of your house and said, right, now I'm going over to electric convector heaters, it would be phenomenally expensive. There are ways of saving money on electric heating. There's economy 7 storage heaters and so on, but that's always seemed to me to be the right answer to the wrong question. How do we use electricity when there's too much of it and not enough of it used at night, rather than how do we get the heat in during the day. We try and heat up a pile of bricks in an insulated box and find out that it runs out mid-afternoon, and then we're cold in the evening. But I would say insulate the thing to within an inch of its life until it's got a really low heat load. And then if you can, use an air source heat pump. But if you can't use an air source heat pump, then your heat load is so low because you've insulated the house so well that maybe you can do the sums and say, well, even with resistance electric heating, it'll still work.
Okay, all right, that's so
I hope that helps.
Insulate first, fabric first, and then look at heat. Right. So Norman has asked, how will works be done indoors during COVID? Norman, it really depends on the person that you're using to do the works. At Celsey, if you're getting a assessment and a whole house plan done, we can do that remotely, but we would speak to you on the phone and ask you to collect some of the data for us. But the rest of the works would depend on the contractor. Amar has also asked that he has heard that older homes need water permeable insulation. Have you got any thoughts on that, Nick?
Yes, I referred to using wood fibre insulation, for example. That's my insulation of choice. That's what I've used in my living room and will be using in the rest of the house when I'm ripping out the stuff I did 30 odd years ago. So basically, houses that were built of materials which were breathable, which would allow a beneficial passage of water to and fro through bricks, through lime mortar, through lime plaster, are not built for covering up in a plastic sheet, basically. Because if you put plastic insulation on the inside with a vapor control layer, you tape up the foil layer to stop water vapor getting into the wall. But it also means that any water that does get in there, and your standard condensation risk assessment assumes that all the water comes from inside. It doesn't. It comes from outside as well, getting a beating from the rain. So water gets trapped in your walls and can't necessarily get out one way. It's far better if it can breathe in and out both ways. So yeah, wood fibre, I would strongly encourage wood fibre or cork, a breathable material which is very dense and which will buffer moisture as well. So it isn't lots of materials, sheep's wool's breathable, but it's not that dense, so it won't buffer moisture so well. Yeah, I strongly believe in it. There are times when I can't use it, but when you do that, you have to take much more of a risk assessment approach. And use it as a sort of problem-solving exercise.
Okay, that's interesting. So I think we will only have time for 2 more questions. But as I mentioned, if you have any more questions for Nick, you'll find his contact details on the slides once we upload them. If you have questions for me, or maybe you might find them in the chat. Someone might be able to drop Nick's details in the chat now. If you have questions for me, it's nadia@celsey.org.uk. But yeah, last 2 questions. So Alexandra is saying that her lounge floor to ceiling windows are leaking heat. Can she put tape around the edges? And what about the actual window panes? Can she cover them with a film?
Yes, tape around the edges. It just depends where the leaks are. I mean, if there is a physical if you can feel the air coming in around maybe where the frame fits into the wall or where the glass is fitted badly into the frame or whatever, then yeah, certainly as a short-term measure, by all means, tape it up. And you can buy, lots of us have probably seen it, cling film type DIY secondary glazing, which it looks like cling film. It comes with double-sided tape. You stick the double-sided tape round your window, you put the cling film onto it. It takes a bit of a knack. It's easy to get all twisted up with it. And then you run your hairdryer over it and it goes ping, nice and tight. And it is remarkably effective. until some idiot like me doing a survey comes along and doesn't realize it's there, points at the window and pokes his finger through it. But you know, as long as you remember it's there and tell any visiting surveyors that it's there, then it's remarkably useful. I'm not saying that it's a replacement for decent double or triple glazing in the long term, but in terms of short-term measures, I wouldn't like anybody who hasn't got the time, or hasn't got the money or whatever, to be denied the right to have an improvement in the energy performance of their house. So there are very low-level things you can do too.
Absolutely, that's great. I mean, we're all about the short-term wins. We're all about what we can do now, aren't we? So last question from Magda is, what is the best method for blocking old vents and chimneys to make them airtight and prevent thermal bridging?
Right. Okay. This really is quite a difficult one, because the if you've got an old chimney which has been blocked up and is no longer used, conventional wisdom says that should be ventilated. So there should be a permanently open vent in the room where the fireplace isn't anymore, and at the top there should be, if the chimney has been slabbed over, there should be an air brick in the side, or there should be a mushroom vent with vents underneath the top of a mushroom cowl, in order that there is an airflow within there so that condensation doesn't occur. But the other side of the coin says that your warm, moist air from the house can go up that chimney, and it will go up that chimney because it's a chimney, it's a passive stack, it has an updraft in it, and it will pull your warm, moist air up the chimney, where as it gets higher up, it may well condense. So the best thing in many ways to do would be to fill it with a granular insulation, but it's difficult. You won't find anyone giving guarantees on this. For a client, I did fill one flue up completely with vermiculite. We were entirely satisfied that the bottom of the wall was not wet, and vermiculite will, for those of you who've used it for gardening, will suck water. So if there's any risk of moisture, you don't want to use it. You could use expanded polystyrene beads. No one's going to guarantee it for you. This is the problem. The other thing the questioner mentioned was the blocking up of vents into the room. This is a question of making sure that you have enough ventilation, but not too much. Most of us have too much because we have not only the perhaps trickle vents that somebody's put in our windows, or the old 1930s 9-inch by 6-inch vent which comes into our bedroom, but we also have the unintentional ventilation, all the gaps around everywhere. It's very boring, but one starting point is to go to approved document F on planningportal.gov.uk and actually look at the ventilation regs and see how much you're supposed to have for each room. And the more that you can baffle that ventilation, or put it, you might use they're not cheap, single room mechanical ventilation with heat recovery fans, not a whole house system, but single room fans in some rooms. They can be very useful. So there's not an unequivocal answer, I'm afraid. But yeah, that's something.
Really helpful. Do you know what? I think you might have solved one of the problems with my house that I've been trying to solve for a very long time. So thank you for that, Nick.
Okay. Send me an email.
Yeah, really appreciate that. What an insightful session. I just thought that before we close, I will remind you of the useful links that we talked about a little bit earlier. So if you can see on my screen that I've gone to the CELSI website, and I'm just going to show you how to access the recordings, how to sign up for future events. So across the top of the CELSI website, we've got our news posts. You want to click on the How to Green Your Home article, and it will take you to this page. What you can do on this page is register on Eventbrite for our next event. The next one will be after the half-term break, so that will be Wednesday the 4th of November at 6:30. And when you register on there, you'll be taken to the Eventbrite page. Just select a date and you will be able to donate once you click on tickets, and you can either donate sort of through PayPal, or you can donate through just putting your card details in, whatever's easier for you. Please do sign up on Eventbrite, because that will help us have your email and be able to send you the link to join. Apologies for anyone that didn't get the link this week. I will do my best to sort out whatever issues there are with that. But if you're wanting to access the webinar recordings, you just scroll down to the bottom of this page, and I will send everyone who's attended today a link to when I upload the next recording. But you click on that for the webinar and click on this for the slides. And then the last thing is, if you're interested in having any of the services that we talked about earlier, just click here and you can register your interest, give us your details, tell us what services you're interested in, give us a bit of background about your building and what work you've had done, and we'll call you back as soon as we launch the program and make sure we get you booked on first thing ahead of anyone else. But what can you do when you go home and after you finish this webinar? We talked about switching your energy supplier. So if you go to our website again and then click on Power Your Home with Community Energy, you can find out more information about our partnership with Co-op Energy. As I said, this tariff is actually powered by community groups across the UK. So people from all over the UK that have solar farms or solar panels or wind turbines that are generating energy go into this tariff. So that is where your energy is coming from. And they also donate to us and to a pot for community energy groups across the UK. So you just click this link and then you'll be able to switch to the community power tariff. You'll go to Co-op Energy and Octopus's website. But yeah, if you haven't switched supply and you're still with one of the big six, definitely check out how you can switch and check out the different deals you can get. Because if you're looking to save money and go green, it is one of the easiest things you can do. But in the meantime, I will leave it at that. I look forward to seeing you in November. I hope you all enjoy your little half-term break in the meantime, and please do look out in your junk email, because sometimes the emails do slide into there for all of the links and all of the details about the next sessions. So thank you for joining that, and I think, Jason, if you wouldn't mind ending the webinar and stopping the recording.
Oh, one moment.
Go ahead, Alex.
Lucy just asked in the chat where she needs to click to get the consultation again. So if you could pop that in and then give her 10 seconds to be able to copy it. So, because you lose the access to the chat if you haven't grabbed it before the call finishes. And whilst that happens, just a huge thanks from the whole Chelsea community for Nick helping us out on our retrofitting learning journey this evening.
It's a pleasure. Thank you.
Thank you, Alex. Which consultation was that? Sorry.
You mentioned about the link for getting a consultation with us via the website. I think that's what Lucy was referring to.
So if you just go through the link that I've just posted now, Lucy, and you click register your interest, you'll be taken to the form there. But yeah, I will send around all the links via email, so don't worry about anything that you've missed. And the chat is also available on the web.
Sorry, I missed the last bit of what you said. The chat's available, is it still?
Thank you. The chat will be available on the recording once we upload that afterwards.
Oh, right. Yeah.
On our website. And thank you, Jason, for helping in the background organising this as well. If any queries, you know where to get in touch. But I will leave you to enjoy the rest of your night and hopefully see you in November. So,
thanks very much. Cheers. Bye.